uh, 10th session expert is Tejas, Mr. Tejas Pandya, highly accomplished software engineer with 11 years of experience in designing, developing, and delivering cutting-edge software solutions. Proven track record of driven innovation, improving efficiency, and leading in high-performing teams. With a strong foundation in computer science and software engineering, he possesses expertise in the range of programming languages, including Java, JavaScript, Python, Angular database, and his experience spans multiple domains, including fintech, healthcare, business intelligence, telecom, TCS, Gensar, and also British Telecom, Cisco, Mastercard, Royal Bank of Canada, and ES skill of programming language like Java, JavaScript, Python, Angular, development framework, Spring Boot, microservices, Spring MVC, database services, Oracle, uh, SQL, Snowflake, Postgres, operating systems, Windows, Linux, and Mac. So we invite him as an expert speaker for the IoT and its applications. Please, sir.
Yeah, I think Dr. Avis has
And
already.
currently he is working in Brilo,
Yeah,
Pune.
yes, I think yes. So I think
Uh,
Dr. Avis has been introduced myself as a like very elaborately. So I think thank you, Dr. Ravish and Mr. Chirag, that you invited me in this session.
Welcome, sir.
And yes, yeah. So I think as Mr. Ravish mentioned that I have been working with 11 years of experience in all of the companies like big giants like TCS, Tech Mahindra, Zensar, and there are multiple clients I worked with like Cisco, Mastercard, Royal Bank of Canada. There is a British Telecom, the telecom like domain. There are multiple domains like financial domain. So I think Mr. Avis has been explained everything. So we are starting with the introduction of the information retrieval system. So it's an application of an IoT. So let me share my screen. So just for the bandwidth purpose, like I switch off my camera, so it will be not like disturbing my presentation. Okay.
Sure, sir.
Let me know once you are able to see.
Yeah,
yes,
sure.
yes.
Are you able to see?
Yes, sir.
Yes, sir.
So this is the application. Okay. So it's a part of an IoT. There are multiple application maybe you are aware of. So this is one part of an application of IoT, Internet of Things. So this is an information retrieval system. Basically, this system is you all aware. You all have touch in day-to-day life. Okay, it's a normal system like you Google search. You have been Google search. You have go to the Amazon, Flipkart. This is all the things are information retrieval. Okay, you are go once you have also your college has been and some uh, intranet portal. Obviously, that has been have some information of your all faculties, your department. This is also a information retrieval system. So basically we are all connected with this system. So it's a normal so what I'm trying to explain you is normally how it works. So there's a big giant like Google. We are touch with Google in day-to-day life. Okay, so there are multiple systems also, like there is a Bing, there is a Yahoo, there are also a information retrieval system. So apart from that, there is a Amazon, Flipkart, Mintra. There is a healthcare domain is also there. So every big hospitals have their own records of a patient, their doctors, their medical files. That is also a information retrieval. So just start with an application. So it's a common introduction. It's a brief introduction. So my PPT itself has the same thing. There are some how we are doing we are in normal day to day life, how it works as a background, like how it works internally that I'm going to explain you today. So there are some topics that these are some topics that I will cover today. So there's a data retrieval versus information retrieval, how previously it was happened, now it is happened in future, what will be the future of IR, and the retrieval process basic concepts, the IR models, the information retrieval models, the ad hoc retrieval filtering, and the classic IR models. Okay. So we can start with the introduction. As I mentioned, information retrieval deals with the representation, storage, and organization and access of information items. So basically, everything. All of you, as everything, know that normally when you search on Google, it will retrieve something. Okay, so it retrieve on basis of something, like how it represents the storage, the organization, and the access of this information items. So basically, the information, the representation and organization of the information item should provide the users with easy access on information which he or she is interested. Okay. So if you are searching something like some movies or some you for example IoT application you are searching. Okay. So it will fetch the millions of records, whatever you search as part of a text like information in internet of things applications, so it will retrieve the millions of records with millions of sites. So this what particular keyword that has been written in each and every site has been retrieved. Normally it's an example of whatever you have searched on Google. So whatever the relevant data has been there on the www that has been retrieved by the Google, and that is the basis of them rank some algorithm has been performed internally. So some search engines are there, SEO has been performed, the search engine optimization is called. Okay. So normally search most IR application visible to most IR applications. So other applications like the digital libraries, e-commerce sites, as I mentioned, enterprise search, healthcare search, multimedia search. Obviously, you gone through the YouTube, you search some videos. It's also information retrieval system. Okay, basically. So how it works internally, that will cover in the slides. Okay, so basically when you're searching something into the Google or YouTube, it will pass as a query. The query, so whatever your question is, just ping into the chat as in the last session I can show, and then I will address in the last. Okay. So basically, whatever your search is processed as a query by the search engine normally. Okay, and whatever the user enters, the information retrieval process begins with the user enters the query into a system. So query means your text statement that what is the application of, for example, what is the application of IoT. This is a statement, and query normally has been formal statement. This query has been formal statement and information that needs the information. So Google needs the information from your site, some keywords from your site. So basically as a string, as a text. Okay, so it will process them and it will search into the domains, whatever the domains has been present as part of a registered domains. Okay, so given user query, the key goal of IR system is to retrieve the information which might be useful or relevant to the user. So obviously, whatever, so example, uh, some you are searching XYZ thing into the on the Google. So whatever your word has been present into the Google text box, this will be searched into the database, and it will be fetch the most relevant records. So sometimes it happens like you are searching some more long string. Okay, so long string, so it will Google has been pick them some of the words, and it will fetch according to the what's most relevant document. Okay, so, and it will emphasize on the retrieval information as opposed to the retrieval data. And normally the data is raw fact, information is processed data. So data we are giving him a raw data basically, and information that processed by the Google has been the processed information, like that it is not like that it will retrieve any of the information. It will retrieve as per the rank system. So there is a internally is behave the rank system on basis of algorithms. Okay, So there are some difference between data retrieval and information retrieval. Normally we are searching information as per the subject. Okay, and there are some data retrievals also on basis of keyword. So whenever you passed a keyword into the data as a in the Google, so it will pick the keyword and search into the databases. There are multiple databases present. Normally there are multiple things are present now. Nowadays there is an index based databases also there. There is a no relational database also there. So previously it was a only relation RDBMS. If you guys knows about the RDBMS, if you guys knows about the relational databases, so you can able to relate those things. uh, so normally this is the difference between the information retrieval and the data retrieval. So what it means that so small errors like in the information retrieval, small errors are likely to be unnoticed. So basically, if you are some if you search something, Google will identify what you are going to search. So it will automatically unnoticed and it will fetch the result with the correct information. While in the data retrieval, you need to be accurate that proper data, proper query need to be inserted into the uh, text box, that it will be no such a way to failure those things. Okay, and not always a well structured semantic ambiguous. It means that normally information retrieval is not always a well structured database. Data is information retrieval, but when you are searching as a data, so it will be defined as structural symmetric. So normally if you know what is the information retrieval, this information retrieval whatever you passed as a on the particular search engines like Google, YouTube, or your e-commerce site. So it will perform some algorithms, whatever the, the result has been fetched depending upon your query search. But whenever data retrieval comes into the picture, it will comes with the particular the perform the particular section with the particular terms. Like if we have searched something, that it will pass to the backend and it will have some database query. It will perform something by with selecting the operations and it will retrieve that all the informations. Okay, so this is the main concept difference between information retrieval and data retrieval. So if you guys know about the data database, maybe you can relate those things. What is the UIR, what is the DDR? Okay, so okay, so the next topic is the past, present, and future of IR. Okay, so basic typically information retrieval. If you know, if you means you can relate those things. Like in the past, if you know there is a table content in the book. Okay, if you have the textbook in your normally obviously textbooks are there. So you can first in the first or second page there is a table content. This is also a information retrieval. So how it works previously, so you have index. Okay, index has a multiple content and it has with the name and then pages against them. It is also a information retrieval. So basically old and popular data structure of the retrieval process of selecting words and concept is associated with the pointers to the related information is index. So if you normally you can all relate those things. Like first you can go to the any of the document. If you have example Word document itself, okay, when you start with the structure Word document, there is a, for example, you have some PDF of a book. Okay, so the starting of the book you can find the index. Okay, so when you're clicking something, it will go to the particular section. Like if you have some introduction of the book and it will click something on the index pages, it will go directly redirect to the a particular page. So it is also IR system in the past. Okay, so basically the two IR problems are a view of a two IR problems. There's computer centered and the human centered one. So in computer centered, so IR problems consist of mainly building up the efficient index, processing user queries with the highly performance, and developing the ranking algorithm, as I mentioned previously, which improves the quality of the answer set. Okay, so whatever you are giving to the uh, computer, like whatever you are giving as a query to the Google, it will, based on some algorithms and ranking system, it will fetch the quality answer sets. Okay, so which is more appropriate to the your query. And second is human centered view. So IR problem consists mainly of the studying behavior of this user, of understanding his main needs, and determine how much understanding affects the organization and operation of a retail system. Okay, so next topic is basically information retrieval in the libraries. So normally libraries were among the first institution of adopt the IR system and information retrieval. In the first generation, the system allow the searches based on the author name and title. If you know, obviously previously, there's a history of the IR. Okay, it allows how you can find a book. A book has been by the author name and a title. The second generation, this increase the search functionality was added, which the searching by the subject heading and the keywords. And the third generation, normally we currently being deployed. Okay, we are normally using this. Okay, the focus on improve graphical interfaces. Like there is some GUI, user graphical user interfaces, that you can means if you go to your any of your college site has been there. Okay, so there is a graphical user interfaces that will provide some retrieval of an information of the electronic forms. Okay, and third is a hypertext features and open system architecture. So basically, these all things are normally the current generation of information security, information retrieval system. Let me know if I like if I have in a if you know if you are not able to understand. So I will stop there, and uh, again I will explain basically. So it's a normal.
Sir,
Yeah,
you can see chat box.
yeah. Let me
They will
uh,
write.
just a minute. I'm just
Uh, there is only one question: can IR be done on big data analytics?
yeah. So all this question I will be addressing the last. So
Okay,
basically,
okay,
yeah, so I will address
okay,
those all questions in the last. So it will be easy for all of us to like go throughout this first, and then maybe we will get the answer of this also in this
okay, okay,
in this. Otherwise, I will reply in the last. Okay.
okay. Continue, continue, sir.
Yeah. Thank you. Yeah. Okay. So okay. So nowadays there is a web and digital libraries. Obviously, so there are the three dramatic and fundamental changes have been occurred due to the advance in the modern computer technologies and the boom of a web. How the boom of a web has been increased nowadays. So first it becomes a lot cheaper. Obviously, you all have the access of the web. Okay, the various sources of information. Second is the advance of all kind of digital communication provided and greater access networks. Okay, there has been a 5G has been coming and the 6G in the next upcoming years. The third is the freedom to post the whatever information some judges use greatly contributed by popularity of a web. Okay. So fundamentally the low cost, greater access and publishing the freedom have allowed the people to use the web and highly interactive medium. So this is the nowadays how it evolved. Okay. In such a interactively the allow people to exchange the messages, photos, documents, softwares, all the things in the chat in a chat conventionally is a low and cost fashion. Okay, so these are the past, current, and the future IR. Okay, and now we are going to do a basic concept of a retrieval process. There is a overview of there was a overview that I explained nowadays till now, and now how it works normally. The retrieval process that normally we are going to see in the slides. Okay, the retrieval process, the basic concept of a retrieval process. Okay, to describe this retrieval process, we use a simple and a generic software architecture. First of all, before the retrieval process can we can initiate it, it is necessary to define a text database. Obviously, there should be a text database. Though how it works, you can enter something into text, it will find it in database. Okay, this is usually done by the manager of the database. So whatever there is a huge database lies in the back end of any of the site. Okay, obviously the Amazon, if you know the Amazon, there's a huge vast database. uh, there has been a multiple databases that are there, relational as well as the index based databases. Okay, so there are the document has been stored into the databases. Okay, the operation has been performed on the text, and there's the text model is there like a text structure and what elements can be retrieved. The text operations transform the original documents and generate a logical view of them. So basically whenever you uh, search something on the Amazon, so it will correct itself. If you have as a Google, as also the Google has correct itself. If you search something wrong, and it will take the exact word and it will search the relevant data for you. So it will transform the original context or original document into some relevant queries, and it will get some logical view of them. So the whatever has been performed internally is basis on their algorithm, basis on the coding, whatever they have been code in the backend side, and whatever the data has been present in their uh, you can say databases. Like they have the inventory, the large inventory is there each and every sections. Obviously, you all have gone through this process, but how it works? It is normally it works like a this like once the logical view has been defined, then database manager, the DB manager has been built the index text. So whenever some databases have the indexing. So indexing help us to retrieving the information faster. So this is the main concept of a index. See, an index is critical data structure because it allows the fast searching over the large volume of data. So when you have if you know there is a tables are present in databases. Okay, so tables is having the multiple columns. Multiple columns is having like if you have that the multiple columns, it will not easy to find the data in a normal way, in normal methodology. You have to perform some indexing onto it, and then you will get because the tables itself having the millions of records. But if you find something in a common, if you have searched some common words as normal words, for example, if you search for example a TV on the Amazon, so it will have the millions of records into this, millions of data into this, and it will fetch according to their indexes. So indexes is more relevant data structure into the backend side. So given that document database is indexed, the retrieval process can be initiated, and user first specify the user needs as we are mentioning our need into the search box, and then is parsed and transformed by the same text operation applied to the text. Okay, and then query operation might be applied before the actual query, and which provides a system representation for the user need, and it is generated. So query is then processed to obtain the retrieved documents. So query has been so normally we are giving them the information in layman language. Our layman language is I for example how to do this, how to do that. Okay, it will take those queries. Okay, the user queries, and it will convert those queries into the IR system into the related query to the database. Okay, so there's a transformation, query transformation has been happened in the backend. Okay, and this has been retired document according to this. Okay, so fast query processing is made possibly by the index structure previously built before being sent to the user. The document are ranked as I mentioned previously. There's a ranking system in the backend. Okay, according to likelihood of relevance. If we search something and basically uh, this has been performed a ranking system of each and every document, and then ranking system has been performed, and then it will be returned the document whatever uh, has been the queried, and the user then examines the set of ranked document in the search for useful, sorry, the useful information. Sorry, so this is the how this process has been defined in a diagrammatic way. So basically, you have the visual interface. Obviously, you have the screen of a Google, screen of a Flipkart, screen of a Amazon. There is a this called a graphical user interface. Okay, so user when enter something, user can only see the GUI, the graphical user interface. You can give the query, you can find something, wanted to find something. You will go to the Amazon.com and then you will write something under the search box. Okay, so this has been query has been generated, and it will perform some operations. Okay, and perform, and it will be used, it will be used as a searching mechanism, and whatever indexing algorithm has been performed in the backend, it will perform onto this query, and it will rank accordingly, and it will return the documents whatever according to your documents means anything. If there is a document called document has, for example, Google have all the documents. Like if we have the static page, if you wanted to find some PDFs, if you wanted to find something else, they all have the documents. And this is I will go to this point. There's a filtration part is also there. If you can search something like if you want a computer science book, okay, the computer science for this author, then this will be a filter out some all the things according to your query. Okay, so this is a, so I will go, this slide is also there for filtering and ad hoc request. I will go through it after that. So this is a system how perform internally. So it will take the records, and that will based on your query, it will indexing, it will ranking, and it will fetch the record to the UI, the graphical user interface. Okay, okay. The logical view of a document. Okay, so basically, uh, due to the historical reasons, okay, documents in the collection are frequently represented through the set of index and terms and the keywords. So whatever the frequently representation of a document is based on the index terms and keywords, or whatever. So you are finding something, you wanted to search something, and you are writing some big statement into the Google. So but Google has been find using the sum of the keywords. Okay, that will not search all the whole the sentence into the in the database, but it will pick some particular state sent words, and it will find into the database, and www to whatever domain has been present in the world. Okay, such keyword might be extracted directly from the text of the document, might be specified by the human subject. Okay, so no matter whether these representative keywords are derived automatically or generated by the specialist, they provide a logical view of a document. So basically, whether the representation of a word are derived automatically or generated by the specialist, they provide a logical view. So you made some mistakes sometimes to write something, but it will provide a logical view of it. It will not like take those words and query. So sometimes if you are not able to find the spelling of particular word, then it will automatically correcting, and it will find the logical view. It will not take the as it is word, and it So if take the as it is, it will not find anything in the Google. Okay, so it will present in the logical view of the document. And modern computers are making the possible present documents in full set of words. So in this case, we can say that the retrieval system adopt the full text logical view of the document. Okay, this is the representation of this. Okay, so with very large collections, however, even the modern computers might have to reduce the set of representative keywords, and this can be accomplished throughout the elimination of stop words such as the article and connectives. The use of stemming, which reduces a distinct keyword to their common grammatical root, and as I mentioned that the stemming, the common grammatical root, is identification noun groups, which eliminates the adjectives, adverbs, and verbs. So normally they will perform their way, like they will the mechanism to perform this searching according to the this grammatical root or adjective, adverbs, and verbs basis on this operation called text operations, the transformations. So it will, whatever your search, it will transform according to their uh, 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 whatever they have mentioned in their algorithms. They have transfer according to this, and it will give the results. The text operation reduce the complexity and the document representation and allow moving the logical view from that full text to that the set of index items. Okay, this is structure what the logical view of a document, the full text to a set of index terms. Whatever we have mentioned here, so this is the way it in the backend it will it will transforming, it will be sending to the index, it will ranked, and it will perform the searching algorithms. Okay. So there are multiple models into the this IR system. Okay, so the classical are there, structure and browsing models. So the three classical models normally is popular: a Boolean, a vector, and a probabilistic. And the documents. So basically, Boolean is normally, if you know, obviously you all know about and, or, and not. Maybe it's a no, it's a Boolean operations. Okay, and or not. So documents and queries are represented set of index terms and also set theoretical. Okay, so normally when you search something, it will perform the and, or, not also in the classical models of IR. It's called a Boolean model. There is a vector model. Okay, there is a document. Uh, this document is there. There is a performed queries onto the vector, and it will d-dimensional space. Okay, there is a diamond. I can see just a minute. I can see you the this vector model also. Yeah, I will go to the last, this vector model and probabilistic model. So documents and queries are represented in the vector. If you all know about the vector, I'm not sure how many of you are the vectors, but in the t-dimensional space, and also known as algebraic. Okay, so algebraic way it will represent this IR model. So it will search according to the vector space. And third one is the probability of theory. The framework for modeling document and query representation is the based on the probability of theory. And the modelization is also there. The set theoretic is fuzzy logic, the extended Boolean, the algebraic. These are the sub content of the neural networks. If you all know about these things, there's a huge, vast area of the neural networks. There's a fuzzy logic. I had also my last year project as a genetic algorithm. I was performed some you can say the traveling salesman problem. So there was a performed algebraic way. The neural networks is also there. The interface network, the belief network. So all the things are the models of this IR. So basic models. this it depends on this classical models only. Okay, so these are the main concepts. So this is the diagrammatic view of the this model. You can see the structure, classical and browsing model. So as I mentioned previously, the retrieval ad hoc filtering is there and the browsing is there. Okay, here and there is a sub part of this, as I mentioned. The sub models are there of a particular uh, all the types of a model, subtypes are there. So the algebraic, the probabilistic, and the belief network and the browsing model. Okay, just a minute. Okay.
Hello?
Yeah, yeah. Yeah, I'm just
Hello?
checking the chat. Hello, I'm checking the chat box only. Just a minute.
Hello?
Hello, hello, hello. I mean,
Yes, sir. No
am I?
issue. No issue.
Yeah, okay. Okay, there's ad hoc retrieval and filtering. As I mean, at the starting, I mentioned something that how it retrieves. It bases on your texts. Okay, so basically, it first of all is ad hoc retrieval. So ad hoc retrieval is normally a process of retrieval document in the response to specific in one-time query. Okay, submitted by the user. So whatever you have submitted as part of a text box in the query and click the search button is an ad hoc request. The system is expected to retrieve the rank and rank most relevant document from a collection based on a query. Okay, so there is a one-time search. The key characteristic of ad hoc retrieval is one-time search, dynamic retrieval, and relevance oriented and general purpose. So normally, one-time search is focuses on a single specified user query. Dynamic retrieval is user provide us query and system ranks documented in real time. And third one is relevance oriented. The main goal is to return the document in the descending order of a relevance to the query. Obviously, whatever the relevant to the query, it has been when it searches in the backend. Normally, it comes with the ascending order. Okay, but it will need to be in the descending order with the most relevant document, whatever have you searched on the Google. And the general purpose, obviously, as I mentioned, if you search something like uh, IoT applications, okay, in the Google, but when you are finding IoT application, it will fetch millions of records. Okay, you have all the things into this records, like all the documents into it, but you wanted to find something, uh, IoT applications for smart homes, for example. Okay, then it will fetch according to the filtration. It will go to the filtration part. It is the next thing. Okay, so like for example, this ad hoc retrieval, for example, searching for climate change effect on polar bears. Okay, in digital library of website, the system retrieves the rank document like research papers, articles, and news reports. It bases on that your whatever you have searched. Okay, for example, now it's a filtering. As I mentioned, there is an ad hoc retrieval. Normally you can search a normal text, and now it based on your filtering whatever search. If you describe more, then it will filter out the things accordingly. Okay, for example, filtering refers to continuous and personalized retrieval. As I mentioned, there's a personalized retrieval. So if you want to find something with some filtration, that I want something like this only, I wanted this topic, but in this topic it will fetch these records only. So this is a part of a filtering. Okay. So normally a long-term user preference in predefined criteria. So unlike it's opposite to unlike the ad hoc retrieval, the filtering focuses on relevance, ongoing relevance, and the adaptive results. Okay. So there are some key characteristics like ad hoc retrieval also. So persistent interest, the monitors a stream of incoming documents to filter relevant ones and based on the predefined profiles and rules. So basically it now it goes to the profiling. Okay. So for example, if you know how would the profiling works, if you obviously know, if you have the two Google accounts, okay, one Google account, okay, for example, I also have two Google accounts. Okay, so for one Google accounts, I only search about my child rhymes. Okay, so when I search it, any in the future, it will retrieve the, it will search, it will give me the same suggestions for this only. For example, if you have that profile and you are searching from this profile and searching something like if you want, if you have want some rhymes, nursery rhymes, okay, so in the future also it will give the uh, same suggestions. Okay, there is a key characteristics of filtering. Okay, if you can relate in real world. Okay, and I have another account, so I wanted to find songs only, the Bollywood songs example. So in the future also it will give the suggestion, I mean, like whatever we search, it will have some they have obviously a machine learning mechanisms. Okay, whenever you search, whenever you do something something on your personal profile, it will uh, take those as a data, and this will perform in future and suggest the same thing in the future. This is normal the characteristics of a filtering. Okay, and the real time updates, whatever the, for example, dynamic matches a new content with a user defined criteria. Obviously, whenever you make more criteria to find the words, it will take real time updates, obviously, and selective retrievals. Okay, so if some not focusing on selecting documents that meet the specific requirements rather than ranking. Okay, sometimes I can see, so there is a dotted lines in the ranking. So you can see here, there was a diagram I saw you. There is a ranking system. Okay, here. So sometimes they will forget, they will ignore the ranking because why it is a dotted arrow into this. Okay, it will sometimes, as per your criteria, if the ranking is not matching, okay, then it will perform their own mechanism of indexing to retrieve the data. This will mention here only. Okay, meet specific requirements rather than the ranking all documents. So it will not rank the all documents. Basically nowadays there are the SEOs are present, the engine optimization. So if you have some, for example, if you have some site, for example, of you are making some product and you are have some own site. For example, shoes. You are making some shoes brand and you have the your own site. Okay, so you need to do some SEO that will rank your site into the higher Google pages. So you can make your site also at the first page of Google. You can have the Google. Obviously, you're searching something. There are multiple pages are displays in the bottom. Okay, so it will according to the rank. Okay, the ranking system. So it ranking and based on the SEOs. So how SEO works. This is a different topic. It's a also huge topic. Okay, so it is like in the backend, it's working like this only. Okay, for example, like email, obviously we have the email filtering, we have the spam. You can see the spam mails are there, there is a priority mails are there. Now the newest update mails are also there, is coming. Okay, news recommendation. Okay, so basically when you obviously you all know the subscription. Okay, the machine, delivering the article related to machine learning to subscribed user. So when you something subscribed, you subscribe some channel on the YouTube. So it will, by using the machine learning techniques, the machine learnings, it will fetch those news. Like if you wanted to show only sports news, it will perform on your profile. The machine learning will perform on your profile, and machine learns that things that you wanted to search, you wanted to show only the sports news. So it will, accordingly, it will take those news from the YouTube and it will show you in the suggestions. Okay, and the stock prices are also. These are some common common example of filtering. Okay. So this diagram is mentioned like ad hoc tables also there, and there is a filtering as I mentioned, that how filtering works. There's a user profile one, user profile two I mentioned. Docs has been filtered in user two and docs for user one. This is the same thing I explained you as part of filter. Uh, okay, the user profile is compared to the incoming document to determine the user interest. So it perform the user interest on the user interest is show according to this. And selecting a news article, this is the same example. And the task is determine which one is really relevant is fully reserved to the user. And whatever this has been written, I have explained you as part of the last uh, slide. The rank document is a vector model. This now is coming to a vector model. If you remember, we show the Boolean model, vector model, and probability stick model. Now, these are since model, and based on this model, the classical models, the rank has been defined, and it will be documented and it will be retrieved. So there is a huge topic. There is a multiple things into the. Uh, I can give you the some links that will also help you to understand how Boolean, how vector, and how probability uh, uh, types of a model work. There are multiple things. Multiple things are there. Okay. I wanted to. These are some. Let me show you. I have some PPT also. Just a minute. Are you able to see the new PPT?
Yes, sir.
PPT, yes.
The second one. So basically, I removed some of the slides. This will have the deep explanation of this model. Okay, basically, as I mentioned you, okay, this one is a Boolean model. Okay, so Boolean model, I mentioned you there is a conditions has been there. The end condition is there. The these are the Boolean
Sir,
operators. Obviously, you all know these operators. This is the same thing has been
are
happened in
you
the Boolean
are you
model.
showing
Hello,
22 number slides, sir?
no, so there's a different slide. I actually removed those slides because I think it's a deep explanation of these models.
Okay, okay,
I will share those slides if you want. Obviously,
okay, okay.
I will share you the slides. I will share you the links. Okay, which will
Okay,
help
sure.
you to understand these models. But I have removed as of now. But I show you how it works. One of this model, for example, we show these models like Boolean model. Okay, you can mention there is a Boolean model. Okay, I removed previously. I thought it was a like it was having the three, four, five slides. There's a huge explanation of it. Okay,
Okay, okay, sir.
for
No issue.
so for example, there's a Boolean operators are there, the and, or, and not. Okay, so this is how it works. This is the work. For example, you are searching something like peanut butter or jelly. For example, this is a term you are searching. Okay, so this is how it works. Like if only it will tell sometimes peanut butter and jelly, it will retrieve the peanut butter and jelly, all the things related to this word or the particular word, and or condition and not condition. This is performed like this only in the like in the backend. This is the same thing that we there's a in elaboration of so much elaboration is there in this. There's a vector model, so there are some vector representation here. I can show you just a minute. I can also show you in this. So there are some queries has been computed according to the documents in query. Okay, so this is a more precise than the Boolean model. Okay, so basically there's a pair has been generated with the ki and dj model. A document has been written, and then a vector document has been represented by this dj.
Sir,
Tell me.
have you opened any another PPT?
Yes, I opened. I removed some slides, so I opened the older version of my PPT.
But right now, right currently in my screen shows the your
Oh,
previous
sorry,
slide.
sorry.
Ah,
Mm, let me show the full screen. Yeah, just a minute. Sorry for this. I also forgot.
ah,
Now you can able to see, I think.
yes, this one. Yes, yes. Boolean model. Yes. Now it's okay.
Yeah. So basically, whatever I defined here as part of these models, okay, there are the taxonomy of the higher models as per the previous slides. Okay, there are classical model, structure model, then browsing model. Okay, so the main classical models are there: Boolean, vector, and probability. So out of this, I removed some slides because of this. There are huge explanation, I think, and maybe this will have you already know this maybe this and or, but it will represent in the way that how it works in the backend for retrieval the information. So this is the if you can see, this is the diagram of this and or not. Okay, you can relate a normal and or not. uh, if you are working as an electrical department, obviously you know this and or not. And there is a vector model, as I mentioned you. It will have this all this uh, pairing system. A bull is more precise than a Boolean model, as I mentioned here. And normally, this weights and indexes term of queries and document has been defined as per the uh, this document. Like dj is the document, and w1, w2, w3 is j are the normally weight associated with the that pair of particular k and j. So this is a huge topic. I think uh, this has some advantage. Disadvantage also. The probability model. It has been assumption has been there. So this is the model. So coming to the last slide also, I'm going to the last slide now. So I will share those slides also. It's fine for you also. And also I will paste some link in this into these slides so you can go to this information retrieval models, because there is a huge, like, as we are performing some introduction, but there's a huge in deep information of these models. You can it is very interesting when you can go to this in deep, because how it works is a very big thing. Like how we are only just searching and it will we are just having that we will get the information, but internally perform so many things as per the slides. Okay, so I will share you. So let me share my last slide again. Okay.
Okay, visible, sir. Visible.
Yeah, yeah. Okay, this is the one. No, this is not. I think I again open the same slide. Let me close this first and again. Yes, now it is. Okay, as we show that the ranking system and all. So basically, it will filter out all the things, and as per the profile, it will take the results. It will fetch out the results, and it will uh, get the information whatever you want. Okay, so it is the same thing that I explained you. The same has been written here. Whenever new document has been arrived as per the profile, it will automatically updated onto the profile. So this how it works and how the profiling and ad hoc request has been worked. Okay, and the last topic normally is the formal characterization of IR models. So basically, IR model is whatever I show you. This is quadruple, like a DQFR, where the D stands for the view, logical view. As I have this, we have the slides of a document collections. Q is a set of logical view as per user queries, and F is the framework for modeling a document and queries. And last one is R, which QI and DJ is a ranking function. So this how it works as a formal characterization of IR models. So normally it seems like this diagram. The document is there and query is there, and above is the document logical view, and the below is query logical view. So and you perform the ranking based DJ and QI, and then we will fetch the data. So this is how it works formally. It's how they defined the query document and framework with the ranking system. Uh, okay, this is the like I think end of the slide. So I most cover the introduction of this part, and I can also share you the details of uh, each and every model. So model is very much important. I think as per the whatever the search engine has been performed internally is based on the model, the classical models. Okay, the and it will uh, fetch all the things according to those models, but it will be a huge topic itself. So maybe I will share some of the links as I find something from the obviously from the Google, and it was very much useful. I think topic if you can have the interest how it works, how the retail system works. So you can find those things. Okay. So I think some questions are there. Let me check this questions first. Mm, okay. Now, thank you. Where is the question? Okay. Okay. It was clear. Yes, obviously, IR can be done on the big data analytics because obviously the big data has performed. We are performing the some IR onto the big data itself. Okay, so normally the big data is very much interesting topic itself also. For example, we have information data system can be effectively applied, we can say. And in fact, there is a crucial role, I think, to perform the information fetching on large scale. And because big data is normally unstructured data, sometimes semi-structured data is also there. So if we have the massive data volumes, I can able you are able to hear me, right?
Yes, yes.
Yeah, okay. So there are multiple things why big data needed the IR. So normally uh, it's if we have massive data volumes, okay, that big data are too much large and complex data structure, okay, in backend. So by traditional method, it won't be fast as much as fast as I mentioned you. There is a indexing, okay, performed on the data. So millions of data has been fetched. So why IR is required here on the big data analytics? Because it has that modeling part, the searching algorithm. They will perform on the big data, and the big data is obviously unstructured data, sometimes a semi-structured data. So the IR technique helps to indexing and searching on the relevant data efficiently, I think. And about the unstructured data, so it will be the portion of a big data structure and unstructured like text, images, videos. Obviously, those are the unstructured data, and sometimes real-time needs is also there. So many big data applications like e-commerce, social media, these are the require real-time or real-time information, near to real-time information. Okay, so there are some scalability is there into this for database presentation like indexing and search, semantic and conceptual search. There are multiple things I think is there. uh, Hope I can answer the question of this. Like obviously we need to do the analytics, data analytics. We use to IR in analytics.
Sir, how it is useful to in smart cities means information retrieval.
Oh, yeah, means IoT,
When
right?
when we
No, information retrieval is basically smart city is a different thing. Smart city is a part of IoT, not a part of IR. Okay, IR is a
okay.
different thing. IoT, Internet of Things, have multiple applications. Obviously, one of them is smart city. Okay, and
Hmm.
second is you have the smart home also. You can use Alexa. You can have Google Homes. This is a part of a smart home. This is IoT applications. It is not IR applications. Basically, so this is like how it works, how the IR has been works.
If
So yeah, yeah. Please ask.
participants have any question, they may ask, and they can write in chat box also.
So what are IR applications? Okay, IR applications are basically I mentioned right in the those whatever you find onto the internet, like whatever you wanted to find, like obviously itself Facebook is also a IR application. This is a data of a person. Okay, so IR applications are basically in multiple domains. Okay. Obviously, I mentioned there is a healthcare domain. Obviously, you can at the time of COVID, like government has maintained all the information of that who has the COVID. So about any of the big hospitals, okay, if it is a big hospital, they have the records of each and every patient. So it is also a IR application. Okay, e-commerce, as I mentioned, the e-commerce is there. The enterprise search means if I have some big company, for example, I worked as a TCS. Okay, I worked on a TCS. So TCS has a 6 lakhs employees. Okay, so the details of 6 lakhs employees itself is a you can say the IR, information retrieval. So normally these are the internal uh, applications of normally IR applications. So anyway, not a TCS is the example of the enterprise search, but there is a healthcare, as I mentioned, e-commerce, Google itself, obviously I mentioned. So these are the IR applications. Right? It is not, I mean, it is like a huge topic. I think I'm not sure. I also don't know much about the internally how it like perform. Google has been perform some coding that will retrieve the information. It's a very much, I know some of the things about the Amazon because I have worked with AWS, Amazon Web Service. I have also worked with some Elasticsearch. So normally if you know the Netflix, okay, if you know the Wikipedia, okay, the Elasticsearch has been there. The Elasticsearch is the non-relation database. Normally we are using Oracle. If you know about the Oracle, there is a index-based database is also there. So it's called Elasticsearch. So Wikipedia uses this. So I think uh, there are multiple things they are using. Google is using something else. Okay, Amazon itself is having their own cloud that will use to store the data and they retrieve according to the database. Mm. This is whatever the information I've shared. Let me know more questions. It's fine. I can address them. We have the time. Okay, some question
There
is there.
is one
Yeah,
question, sir,
yeah. Yeah.
in chat box.
How can IR
IR
system
system can be designed to support real-time decision making and autonomous system in IoT environments.
okay, just a minute. How can IR system can be designed support real time decisions and automation autonomous? Okay, there are the key some of the I think key characteristics are there. I think I mentioned the real time processing, the context awareness, the autonomy. Okay, so this is designing a information system support real time and decision making autonomous system in IoT. Okay, that involves normally adding challenging things like scalability, adaptability. I think so. I'm not sure that there is a system must process the vast amount of streaming data. So obviously you have the big data as a previous question. I obviously it defines it has they have the characteristics like scalability on heterogeneous data also there on data handling. Okay, and architecture is also there for designing the real time. So there is I think I read somewhere there is a stream processing frameworks are there. Okay, you can say there is a Apache Kafka. I'm not sure you are aware of this word. There's Apache Kafka, Apache Spark streaming, and Apache Flink. There are some applications, okay, of stream processing that will real time you will fetch data. For example, if you can see that what you I can give the example of real time data is the stock exchange. So normally Apache Kafka is the application framework. It will use the real time updates. It will use to fetch the real time updates. Okay, in IR. So it will need to be integrated as an architectural designer designing into the IR systems. So uh, this is the way we can obviously compute. We can take the support of real time decision making or autonomous system with IoT environments. So there are multiple applications that I mentioned, and there is a real time. Obviously, yes, the query optimization is also there. The real time decision making. So based on the predefined indices, we can use the common queries, and we can get the real time data. Also, we have the conceptual and semantic understanding. So it will use this. Obviously, AI and machine learning, how we can forget, so we can use this to integrate with IR that will take the real time data and decision making techniques is the main thing. AI and main concept behind the AI and machine learning is the decision making. How how the system itself make the decision of do the things. This comes with the AI and ML. So this is the thing. There are some technical technologies are there. I mentioned Apache Kafka is there. Elasticsearch I mentioned is also a search and indexing mechanism. Uh, there is a IoT platforms like AWS I mentioned as IoT core. There is all three of the main like uh, Google cloud platform are there. This is also IoT platforms like AWT, Azure, and Google. Three Azure is with Azure is of the Microsoft. AWS is also with Amazon, and Google itself has a cloud. So these are the technology that has like comes with we can like combine with IR and we can make those application as autonomous and also the real time updates you will get. Is there anything? If I let me know if
we can say that Google is main mm, in source of information retrieval.
yeah we can say that we can say because it comes with the www domain because it will fetch all the domain and it will return all the keyword that you find from the domain level. So Google is the main information. Bing is also there. If you know about the Bing, it will comes with the Microsoft Edge. If you have in laptop, you should have the Microsoft Edge. So it will search into the Bing automatically. It will not search into the Google. You need to go to the google.in and then you can search. But Bing is also there. It was Yahoo is also their search engine. So there are some search engine, but yes, Google is the main like it is the main information retrieval system. You can say domain
Okay,
wise also
thank you,
there.
sir.
Yeah, yeah.
Thank you. Any participants have any question? They may ask. We have time. Uh,
Yeah, we
10
have time.
minutes
Yes,
yet.
obviously.
Yes. So they can ask, raise their hand. We can unmute them.
Sorry, I was.
Okay, sir. Sir, one group photo, please.
Yeah, yeah, sure.
Please, participants, please turn on your camera so we can take one photo, uh, group photo.
I will share this whatever links I have which is informative. I will share those links as well as this PPT also to you to
Sure,
Dr.
sure,
Avish.
sure.
Yeah. Maybe
Yes, yes,
it will help you. Yeah.
yes. I will share with our participants.
Let me know if anything like any question is there. We can have the minutes or you can also like if you have question after the PPT, show the PPT. You can also ping me. It's fine.
Participants, please, if any question, they can ask. Okay. Thank you.
Thank you so much.
Thank you very
Thank
much,
you,
sir.
sir,
Thank you so much. Yeah.
for accepting our invitation for the ATAL FDP online on IoT and its applications. And
Yeah.
nicely deliver your session on information retrieval
Oh, thank
and
you so much, sir.
IoTs.
Yeah, inviting me and yeah, let me know if anything is needed. Yeah. Thank you so much.
Okay, sure.
Surely,
Thank you,
sir.
sir.
Be back.
Thank you.
Bye. Yeah. Good night. Yeah. Good night to everyone.
Good night.